Okay, I'm going to have a go at question 9 from exercise 11.5. This is the one that we tried to do in class, and I think a few people got confused, so I got a little bit confused as well. But here's the second go at it. So question 9 from exercise 11.5. The first answer, I think most people understood. We're just working out the probability of the person winning a tournament at a best of 3. So he either wins the first 2, or he wins the first, loses the second, wins the first, or he wins, loses, lose, wins, lose, wins, loses, or lose, loses. Those are all the possibilities that could happen out of a best of 3 scenario. And 9A says, what's the probability that he wins the tournament? So out of all of these possibilities, he can have this one, I might even put them in yellow, he can have this one here, or he can have this one here, or he can have this one here. Those are the 3 possibilities of him winning the overall tournament. Every other time he loses the tournament. So to work out all of these probabilities, we just do the calculations over to my right, as you can see them, and it ends up being 0.784, as you can see down there. Okay, I won't go through all of those. Hopefully you can understand that a little bit. Now I want to talk about B. Now, there are a variety of ways of doing this, but this is the one I want to show you. Now, there might be quicker ways of doing it, and I don't mind as long as you do understand this way as well. So B says, and I've written it down here in sort of mathematical language, this is what you'll use in year 11 and 12. Given that he won the first game, what's the probability that he wins the entire tournament? So that's what this is saying here. This line here, it says, this line is given. So, given that he won the first game, what's the probability that he wins the tournament? Now, I'm going to draw all the possibilities of that down here on this tree diagram again. So, it's the same tree diagram as up here, but I'm going to remove some of the options because some of them just don't exist anymore. So, I'm only using the top options because it doesn't matter that he lost, because it says given that he won the first game. So, all the losses we can ignore now. Now, given that he won the first game, it's still possible that he loses the overall tournament. We don't want that. We want when he wins the overall tournament, but it's possible that he loses the overall tournament. So this now here becomes our 100% group. Okay? So the way that we work this out is, if I was going to use the mathematical language, I would say that turns into what's the probability that he wins and he won the first game. Divided by the probability that he won the first game. Now the reason I do this is because this bottom bit here, won the first game, is all of these options here, and then the top bit is, that's my 100%, and the top bit is wins, he wins the first game, and he won, and he wins the tournament. So this one and this one. So now again in yellow I'll put all the options of him winning, that one and that one. So those are the options of him winning the whole tournament, but it's still out of all of the options here. So this then becomes, becomes wins the first game and wins the whole tournament. So wins the first game and wins the third game. So 0.49 plus 0.147 divided by, he wins the first game, and that's the only thing that we've got. That's our 100%. So it doesn't matter whether he won the whole tournament. Now on the bottom, that one becomes 0.49 plus 0.147 plus 0.063. Okay? And that, when we do that, I think, I've done this before, but I think, so when I do these calculations, 0.49 plus 0.147, that's 0.637, and 0.49 plus 0.147 plus 0.063 is 0.7. And when you do those two things divided by each other, that becomes 0.91, which is the answer. Now, a few other people were saying in class, and quite rightly they were correct, that you could just do, that he's already won the first one, so then what's the probability that he wins the tournament? Well, they were saying you could actually cross this out because you already know that, it doesn't matter anymore, it's a given. So now we just do the probability he wins the tournament is 0.7, and then the probability he loses the next game and then wins the next game is, so this one becomes 0.7 plus 0.3 times 0.7, which ends up being 0.7 plus 0.21 which is, of course, 0.91. And that's an acceptable way of doing it as well. I really would like you to kind of know both of them, because sometimes the questions are not as straightforward as that, but that's very good. I hope that makes sense. If it doesn't, please let me know and I'll explain it to you a little bit more. Okay, I also want to go through the working out of C. I won't do the whole question, but question C says, what's the probability that he wins the whole tournament, given that it lasts for 3 games? So again, I've got my tree diagram down here. What I'm going to do is I'm going to, in orange, or in a different colour, green, let's say, I'm going to put down all the possible ones for when it lasts 3 games. So we know that it lasts 3 games this time. So we know that it could be this one, or this one, or this one. Those are the options that it could be. And now I want to go through and I want to work out the probability that he wins the tournament. So now I look at the ones that I actually want, and I might do this in a red colour because it'll be a bit different. So the probability he wins the tournament is, that didn't work at all, did it? I'll just draw over it. It's this one here, and this one here, out of the 4 options that could happen. So we work out all of the probabilities for that, for the 2 wins, those 2 go on the top, and all the ones on the bottom are, the win and the losses on the bottom as well. Hopefully that makes sense. If it doesn't, please ask me and I'll let you know.